Hi guys, welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining me here today for the second in our series of lessons on linear equations. In our last video, we talked about the standard form of a linear equation, and we talked about different types of problems that can be modeled very quickly and easily by using the standard form. We also talked about the fact that standard form of a linear equation allows us to graph the line that models that situation very quickly and easily by using the x and y intercepts. If you have not checked out that video, I would encourage you to go back and check that one out before watching this video, as I think you'll find it both interesting and helpful. For today, we're going to talk about a second pattern that occurs with linear equations called the slope-intercept form of a linear equation, and it goes something like this. The slope-intercept form of a linear equation is a useful way of writing equations so that both the slope and the y-intercept are clearly identifiable. You'll remember that the slope has been defined as the ratio between the vertical rise of the line and the horizontal run of the line, and in our last video we talked about the y-intercept as being the point where the line crosses the y-axis. So, in fancy math speak or math talk, the slope-intercept form of a linear equation is y equals mx plus b, where m indicates the slope or rate of change or growth of your pattern, and b indicates where your line crosses the y-axis. If I want to get really fancy and use function notation, I would just replace the y with an f of x, and the same thing would occur. F of x equals mx plus b, where m is the slope and b is the y-intercept. Let's look at a couple examples. Notice what we have here is we have the graph of the linear equation y equals 2/3 x plus 2. And I want you to notice a couple things. Right here, this is the point where our graph crosses the y-axis. And you'll notice that if we start off here at 0, 1, 2, we are crossing at the point 0, 2. That also happens to be the value that you see here on the end. The reason that occurs is because if you put a 0 in for the x, 2/3 times 0 makes a 0 plus 2. This will always give us the y-intercept because anytime we put a 0 in here, regardless of what this value is, it will become 0 and get added to whatever this number is. Notice, by the way, that our rate of increase is 2/3. So if I start off here at 2, our slope says we will be rising 2 spaces every time we run 3 spaces. So I'm going to start off here at 2 and go up 1, 2, and then over 1, 2, 3. That gives us this point. We could also do that as a -2 over -3, since 2 negatives would make a positive, and we could do down 2 and backward 3. So in the case of this linear equation, we would say the slope is the 2/3, and the y-intercept is 2. Make sure when you give the y-intercept that you give it in coordinate form, the point 0, 2. How about this one? Can you spot the slope and the y-intercept? I'm going to assume you've already paused the video and tried that if you wanted to. Take a look here. You have a slope of -2. And you have a y-intercept that goes to the point 0, -1. Notice our pattern says plus b. If I change this to addition, this would be plus a -1, which is where this comes from. In fact, if you look at the graph, you can see you go through 0, -1 here, and you can see that your slope is -2. That's down 2 every time you go over 1, down 2 every time you go over 1. That's cool, right? I think this is probably one of the easiest ways for us to graph a linear equation, and I would think most mathematicians are going to be on the same page with that. We love to use this because it's a very fast, quick, easy, and effective way to get our graph quickly. So what I'd like you to do is pause the video, and on a sheet of grid paper, hopefully you have that in front of you, I would like for you to identify the slope and the y-intercept for example A here. I'm going to assume that if you wanted to do that, you already have, and I'm going to go ahead and work this out. If you spotted those, make sure you graph them before watching what I do next. Your slope is, I should say your y-intercept is this point right here. It is the coordinate 0, 3. So I'm going to plot that point here on my coordinate plane, over 0, up 3. I then look over here and I can see that my slope is -2/3. That means I'm going to go down 2 every time I go to the right 3 spaces. Down 2, right 3, there's another dot. Down 2 more, right 3, there's another dot. down 2 more right 3, down 2 more right 3. It is a good idea to put several points along the way because when you're trying to draw with a ruler or a straight edge, it's very easy to get off slightly when you're connecting your first 2 points, and gradually you'll get further and further off as you extend that out. Since I went down 2, right 3, I could also go up 2, backwards 3, because negative 2 divided by 3 and positive 2 divided by negative 3 are both the same thing. And I would extend that the other direction, giving you this graph. Not too bad, right? We're going to give you a moment to try the next couple of these. Again, I'm going to recommend you pause the video between each one and try it on your own before just watching me do it. That's going to be far more helpful for you than just following along as I do it. When I look here, I can see the negative 2 here tells me my y-intercept is 0, negative 2. So I plot that on my graph. I start off at 0 over, 2 down. My slope is a positive 2. That means I'm going to rise 2 every time I run 1. If it helps you to think of this as the fraction 2 over 1, you certainly are welcome to write it that way if you like. So I go up 2 over 1, put a dot. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I can do down 2 and backwards 1 if you want, because negative 2 divided by negative 1 is also positive 2. And we like to put lots of points because it helps us make sure that our line doesn't get crooked on accident. And there's your graph. I did put them both on the same coordinate plane for saving space, the first one being the blue line and example B being the purple. Here's another one. Here I look, my y-intercept is a 0, 1. My slope is here, it is a negative 1. Negative 1. Keep in mind that anytime you don't have a number in front of the x, it is a negative. So I plot 0, 1 on my graph. My slope is down 1 over 1, and I continue that pattern in both directions. Notice that occasionally, if it's something easy like up 1 over 1, I won't necessarily draw all the dots, but I will follow the pattern up here to the ends to make sure that my line ends up being straight. How about D? I have a y-intercept of 0, negative 4. This has a slope of, there's no number here, so it is a positive 1. I put my dot at 0, negative 4, up 1 over 1, up 1 over 1. And then again, I extend that pattern out, not necessarily drawing every dot along the way, but making sure that I have points that are far enough out to get my line straight. What do you think? Not too bad? Tell you what, here's a couple more. Give that a shot. I'm going to assume you've already done it on your own. Here, my y-intercept is 7 or 0, 7 if I state it properly. My slope is negative 4. So I start off at 0, 7. I go down 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. And I continue that as much room as I have. And there you go. This one tends to throw people off because we don't see the y-intercept. Can you guys see it anywhere? Hopefully you recognize that this is y equals mx and that there would be a plus 0 on the end. Remember, the identity property of addition says adding 0 does not change your answer, so you can do it anytime you like. That means my y-intercept is 0, 0. You can see my dot coming in. My slope is 3/5. That's up 3 and over 5. Up 3 and over 5. You could also do down 3 and backwards 5, down 3 and backwards 5 if you like. The important thing is you want to make sure that you have plenty of room so that your line doesn't accidentally go the wrong way. What do you think? I like this. There again, I think this is pretty fast. It's pretty efficient. We don't spend a whole lot of time trying to graph those. I'm going to suggest that you pause the video and try these next 4 on your own as well, and then just watch me do them when you're done. If you feel pretty strong with these, you can certainly feel free to skip through these using your fast forward and just jump to the next slide. I wanted to make sure I gave people lots of practice. Here, my y-intercept is negative 4. My slope is positive 3. That's up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and you certainly can do backwards as well. Here, I've got y equals 6x plus 1. Your y-intercept is positive 1, and then you're going to go up 6 every time. Notice that when you get those larger slopes like plus 6, plus 7, plus 8, you're not going to be able to fit as many dots on here as you could when the slopes are smaller. That's really not a problem because these are already pretty well spaced out. Example C is one that tends to give people trouble. Your y-intercept is negative 3. Your slope, you'll see again, there is no number here. It is negative 1. That's down 1 over 1 every single time. And again, give yourself enough dots that you can see it. Last one, example D. It says our y-intercept is 8. So I'm going to start off at 8. My slope says go down 3 every time I go over 5. That's here. I start off at my dot. I count the number of spaces I cross. I cross 3 spaces. I cross 5 spaces. And so on and so forth. You can also do up 3 and backwards 5 because positive 3 divided by negative 5 is in fact the same value. And there's your graph. I find that most students really enjoy doing these. They actually get kind of fun after a while. You'll notice that we cranked through, goodness, I don't even know how many, 1, 2, 3, 10 examples here very, very quickly. And that's really the beauty and the benefit of slope-intercept form, is we can get those graphs very, very fast. Now, I want you to think of a couple things real quick. There are 4 possibilities that can occur when you are looking at slope-intercept form of an equation. Sometimes you're going to get a slope that's positive. When you look at the graph of those, that means when I go up positive 3, I'm going to go over positive 5. Positive, 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 positive. Whenever you get a positive slope, you're going to have a graph that rises from left to right. I can do the same thing with a negative, negative, because 2 negatives make a positive anyway. So instead of going up 3 and over 5 or up 2 and over 10, whatever it is, I could also use down and back. Either way, when you get this to occur, when you get a positive slope, you're always going to have a graph that goes up and to the right. Sometimes you will get a negative slope. For example, negative 2 over 7. This says go down 2 over 7. Certainly that's not drawn to scale. Down 2 over 7. Every time I go down and to the right, remember this is positive is up, negative is down, positive is right, negative is left. So I go down and to the right. Notice that my line will slant down and to the right. The same thing happens if I put a positive 2 over a negative 7. I go up 2 and to the left, up 2 and to the left, and I end up with the same graph. If your slope ends up being a negative number, your graph will always slant down from left to right. The ones that tend to throw people off the most are things like this. In this example, you'll notice you have a horizontal line, and we say that it rises 0 no matter how far it moves left or right. You'll remember your slope, or m, is your rise, see if I can write that really fast, not neatly, over your run. No matter how much over I go, if I rise 0, no matter how far I run, that should be a number symbol, that's really awful. No matter how much I run, 0 divided by anything is always going to give me a slope of 0. Horizontal lines have a slope of 0 every time. I put a little star next to that. That's a confusing spot for many, many students. Conversely, you'll notice that when you have a vertical line, we say that the slope is undefined. The reason for that is if I'm finding my slope and I'm looking at the rise over the run, you'll notice that no matter how I compute my rise, no matter what number I get on the top, the run is 0. I didn't go over at all. And we've known for a long time that any number divided by 0 cannot be computed. In other words, you cannot calculate how much it rises, but it does not move left to right. This has an undefined slope. Sometimes we say this has no slope, but I find students find that to be more confusing. It is important for me to note that people often mix up this no slope or undefined slope with a 0 slope. It does help me if I go back and think of my rise over my run, and I just remember that 0 divided by anything is 0, and anything that is divided by 0 cannot be calculated. These two right here will cause people to miss more problems on our unit test in my class than just about anything else. And I tend to ask it several different ways. So I would put stars next to those and pay special attention to them. How about this? Sometimes you will be given a line or the graph of a line, and you will be asked to give the slope-intercept form of the equation. We could use the same techniques we used in the previous slides to figure that out. The first thing we've got to do is ask ourselves, what is the y-intercept? Or where do we cross the y-axis? Well, that's the coordinate 0, 3. The second thing we're going to ask ourselves is, what is the slope? How much does this rise compared to how much it runs? Because that's what controls the steepness of my line. Can you calculate that? Well, the rise divided by the run in this case is a rise of 2 and a run of 6. Or in simplest form, a rise of 1 and a run of 3. You can see here if I rise 1 and run 3, I still end up with a dot on the line. Once I know my slope, 1/3, there we go, and I know my y-intercept, 0, 3, it's very easy for me to give a slope-intercept equation. Remember, slope-intercept equation says y equals the slope times x plus the y-intercept. So our solution here, y equals 1/3 x plus 3. Notice when we write the equation, we just give the 3 because if I stick a 0 in for x, 1/3 times 0 plus 3 would give me the y. Does that make sense? Try this one. Again, pause the video, do this on your own. I'm going to go ahead and do this so that you can see. Hopefully you've already tried it on your own. Notice that I cross the y-axis here at the point 0, -1. And then I begin to calculate my rise and my run. Notice I'm going down and to the right. That means I'm going to have a negative number divided by a positive number. So I'm going to have a negative slope. In this case, it's down 10 and over 14, or down 5 and over 7. Notice here when I did the -10 and the 14, I computed from this point to this point, and in simplest form, it actually gives me the distance between this point and this point, or this point and this point. It doesn't matter which 2 points you pick when calculating the slope. If they are both on the line, when you put them in simplest form, you will have the correct slope. Using y equals mx plus b, you get y equals -5/7 x, and then of course you have your -1. There's your solution. I'm going to try it again. I'm going to assume you've already done that. I'm going to look and see where do I cross the y-axis. I cross right here, so my y-intercept is 0, -5, and then I'm going to use my slope. Notice that this is going to be a positive and a positive, so I'm going to end up with a positive slope. In this case, it's up 12, right 3. That simplifies to up 4 over 1. That would give me this point. Up 4 more over 1 would give me this point. So there's your slope. Y equals mx plus b means y equals, there's your slope, 4, and your y-intercept, -5. Y equals 4x minus 5. Piece of cake, right? People really enjoy doing it this way simply because it is so quick and easy for you both to get the equation from the graph and also get the graph from the equation. Here's where the difficulty comes from. Sometimes you will be given an equation and it will not be given to you in slope-intercept form. The rules that we just talked about only apply when the equation's in slope-intercept form. So if you wish to graph this using a slope and a y-intercept, what you're going to have to do is you're going to have to take whatever equation they give you and you're going to have to rearrange it into slope-intercept form using your properties of algebra. Hopefully you're still comfortable and familiar with those. Let me walk you through this first one very quickly. My goal is to get the y by itself. Remember, we're looking for y equals mx plus b. So I need to get this x over to the right side of the equation. Since it is added to the 4y, I'm going to subtract it from both sides and get 4y equals -x minus 2. Notice I could have written this as -2 minus x or -2 minus x, but the pattern says we want the x first. So I went ahead and put the x first. The next thing I need to do is get rid of that times 4. So I'm going to divide both sides by the 4. Remember, 4 divided by itself is a 1, leaving me with just y. And then don't forget, I have to divide both of these by the 4. -1 divided by 4 is -1/4 times x minus 2 divided by 4 is 1/2. half. That is your slope-intercept form for this linear equation. This equation and this equation mean the exact same thing. We've just rearranged it to look slightly different. Once you have this in slope-intercept form, you can quickly see that your y-intercept is negative a half. So I'm going to come over here to this first graph and I'm going to put that as a dot. We don't like it when our y-intercept is a fraction, but it can't be helped. We just got to make sure we're extra careful. Remember, 1/2 would be between the 1, or negative 1/2 would be between the 0 and the negative 1. Notice that your slope is negative 1/4. That means from here we're going to count down 1 and over 4. Since I'm in the middle, or negative a half, down 1 would put me at negative 1.5. Over 4 would go over here. Down 1, over 4 more, and I'm going to continue that. Remember, you can also go up 1, backwards 4, and get the same thing, and there's your graph. Remember, this is not the only way for you to graph this equation, but it is a very quick and easy way. Some of you may have noticed when you had it here that it is already in standard form. If you wanted to in standard form, you could plug a 0 in for the x and find the y-intercept, and then plug a 0 in for the y to find the x-intercept, and you would be able to graph that as well. You know what, let's do that. If x is a 0 and I solve this for y, remember the x would become a 0, I would get negative 1/2. And if I were to erase that, let's see if I can erase that real quick. If I were to erase that and I were to instead plug a 0 in for y, that would become a 0, and you'd see x is a negative 2. Looking over here at our graph, notice your y-intercept 0, negative a half, your x-intercept negative 2, 0. And it would have ended up being the same graph. It's nice for us to have some flexibility in how we can do these. You're going to find that some equations are easier to graph in standard form. Others are going to be easier to graph in slope-intercept form. Fortunately for you, you're going to know both and be able to move back and forth between them. For the rest of this slide, we're going to practice taking our equations and putting them in slope-intercept form. So I'm going to recommend you pause the video and try and rearrange negative 6x minus y equals 8 into slope-intercept form, and that you try and graph that, and then see if what you've done matches what I'm doing. I'm going to assume you've already done that. Let's go ahead and add 6 to both sides. Remember, we need to get the y by itself. Notice this y still has a negative 1 in front of it. So I'm going to divide both sides by negative 1, and I get y equals negative 6x minus 8. Remember, divide them both by negative 1. There's your y-intercept, so we're going to put that as a dot right here. And then here is your slope. This says go down 6 before going over 1. Notice that down 6 and over 1 takes me off my graph. So instead, I'm going to reverse this. Instead of down 6, right 1, I'm going to do up 6 and backwards 1, knowing that these two are equivalent. So up 6, back 1, up 6, back 1, and then up 6, back 1. There's your line. Again, pause the video, try this one on your own. I'm going to assume you've done that, and I'm going to work through it. Add 5x's to both sides. I should have put a plus sign there. Notice that you've got a negative sign in front of your y. We want to get rid of that. How do we get rid of a times negative 1? By dividing by negative 1. Make sure you divide them both by negative 1, and you get the slope-intercept equation, y equals negative 5x plus 2. Down here on the graph, my y-intercept says start off at plus 2 and go down 5 over 1. Not too bad, right? Last example, subtract 2x's from both sides. Divide both sides by the 3. Make sure you divide them both by the 3. You get negative 2/3 x plus 5. That means we're going to start off at 5. Notice that's right here. And we're going to go down 2 over 3. Down 2 over 3. Notice you could also do, instead of down 2 over 3, you could do up 2 backwards 3. And you get the same thing. Hopefully you're feeling pretty confident in your skills at this point. There are a couple other things I do want to make sure that I point out to you before we end the video. Just a couple little nuanced things that tend to pop up. Sometimes you will be given your information in a table, and they will ask you what the slope is. Remember, your slope is how much you are rising compared to how much you are running. The rise is how much your y, or up and down, changes. Your run is how much your x changes. So when I'm looking at this example, 425, 7, 18, 10, 11, and 13, 4, if I were to look at how my x's change, I'm growing by 3 every time. If I were to look at how my y's change, I can see that I'm going down 7 every time. Once I realize that, it's very easy to write my slope. My slope is my change in the y's compared to my change in the x's. Your slope is negative 7/3. Now you could write that as a mixed number. However, since slope is typically rise over run, it's generally considered a bad idea to make that into a mixed number. Can you do it on this one? I'm going to assume you pause the video, try it on your own. Notice your x's are growing by 2's, your y's are growing by 8, so your slope is 8/2. And of course, you can simplify that to 4, or 4/1. How about this one? Can you do that? Your x's are growing by -1, or going down 1. Your y's are not growing at all. That makes your slope 0/-1. Or in simplest form, you're rising nothing. No matter how much your graph goes over, it's never ever rising. Can you think about what that looks like as a graph? Hopefully you realize that's a horizontal line. Well, mine's almost horizontal. It should be a horizontal line if this is your x-axis or your y-axis and this is your x-axis. Remember, there's no rise, it just keeps on running. Horizontal line, and of course I wrote over top of that. Let me get rid of that for you. There you go. Last one. Notice that your run is 0, your rise is +2. So when you write your slope, you get 2/0, which is undefined or no slope. This is a vertical line. No matter how far up I go, I never go anything right or left. Again, it's just something that pops up every once in a while that if you've seen it, it seems real easy, but if we don't mention it, people have a tendency to struggle with it. The other thing I'd like us to be able to do is I'd like us to be able to write these slope-intercept equations and graph them when you're given your description in words. Now, again, this is not overly complicated, but there's some language things we want to make sure we've seen before we go and try and do this on our own. I'm actually going to change my pen color. I think I'm going to switch over to a blue from that red. It's a little less obtrusive. Let's see what this says. Suppose a linear function. As soon as I see linear function, I know that whatever it is, it can be a y = mx + b. I'm going to write that down. Models a relationship where the dependent variable. Remember, the dependent variable from our functions unit is always y. It increases 4 units for every 1 unit the independent variable. That's x. Increases. I want to pause for just a second because they just gave you a whole lot of information here. They've told you that your change in y is a +4 every time your x changes 1. That's a slope. It rises 4 when it runs 1. Let's see what else it says. Graph g when g sub 0 or g of 0 is -8. You'll remember from our functions unit that when we input this value, this is what comes out. When your x goes in, your g of x or your y value comes out. This is your y-intercept, -8. So I already know my slope is 4. I know my y-intercept is 0, -8. Therefore, this should be pretty easy to graph. I start off at -8. I rise 4, run 1, rise 4, run 1. And I can continue that. It says identify the slope. We've already done that. It says identify the y-intercept. We've already done that. It then says identify the x-intercept. Once it's graphed, that's really easy to spot. It's right here. So this is an x-intercept of 2, 0. Now notice the question did not ask you to give the slope-intercept equation, but we can do that as well if we want to. Y equals, there's your slope, 4x, there's your y-intercept, -8. So I cleared that stuff out for you. Let's try another one. Suppose a linear function h models a relationship where the dependent variable increases 3. For every 5 units, the independent variable increases. Graph h when h of 0 = 6. Identify the slope, the y-intercept, and the x-intercept of the graph. Hopefully you've paused the video and tried this on your own. Notice this rule is function h. It says the dependent variable, or y, increases 3. Every time the independent variable, that's x, increases 5, that's a slope. Your slope is 3/5. Y changes 3 when x changes 5. Your y-intercept is also given. Graph h when h of 0 equals 6. So a 0 goes in, a 6 comes out. There's your y-intercept. When you go to graph, you start off at 6, you go up 3/5, or down 3 backwards 5, and you get your graph. Once you have your graph, the x-intercept is pretty easy to spot. It's that point, wow, it's that point -10, 0. Notice I cut and pasted that and I didn't get that edited. I will get that fixed here very shortly. Not too bad, right? Keep in mind that you could have a graph that decreases just as well. If your y decreases, that's going to give you a negative slope. Let's do one last example. This is going to be a little bit more contextualized problem, but the principles we've learned are going to be the same. I'm going to go ahead, come over here and grab my pen because I'm going to want to make some marks. A submersible exploring the surface of the ocean floor begins to ascend, or go up. Opposite of descend. It's going to go up to the surface. The elevation h in feet is modeled by the function h of t equals 250t minus 4,000. Notice this is the slope-intercept form of an equation, or more precisely, the slope-intercept form of a function. H of t, you'll remember from our function unit, means the same as y, and t is going to be the same as x. Since we're dealing with a function here, notice over here on the far right, I'm going to go ahead and label my x-axis as t, and my y-axis as h of t, and I'm going to go ahead and put a 0, 0 at the point where they cross. Now, since I'm talking about a submarine and going up as time passes, I know I'm only going forward in time, so I don't bother to draw the left side of my coordinate plane. I also know that the submarine is not going to go above the surface of the water, so I do not bother to draw the top part of my coordinate plane. I'm only focusing in on the portion that I need for this graph. Let's keep reading. Where t is the time in minutes since the submersible began to ascend, graph the function identifying both domain and range, and then interpret the slope and the intercepts. Well, let's see. We can tell pretty quickly that we're going to have a y-intercept of -4,000. We're told that that's where we begin our process. At 0 seconds, we're 4,000 feet below the surface. And we're told that we're going to go up at 250 feet per minute. That's our slope. When I go to graph this, I have to make sure that my graph goes all the way down to -4,000. So I'm not going to count by 1s or 5s or 10s. I think I chose, yes, to go down by 500s. And notice I just labeled every other one. You can do that. You want to make sure that you've given yourself some room so that like -4,000 isn't right here and you end up with a tiny little graph. But you also don't want to have this extend all the way down past the end of your paper. Sometimes estimating what to count by is the hardest part. When I count my time, I don't really know how long it's going to take, but I can see I'm going up 250 per every minute. That's pretty quick, so I'm going to go ahead and count, I think, by ones. Yes, 1, 2, 3, 4, 5, and so on and so forth. And then I'm going to begin my process of graphing. Notice I start at 4,000 feet below sea level, and I'm going to go up 250 feet every minute. Since I'm counting by 500, 250 would be halfway over 1 second. 250 would be the other half over 1 second. And now I can see that up 250 every second is the same as up 500 every 2 seconds. And that's going to make this a lot easier for me to graph. I'm going to connect my dots. Remember that these are sample points along the way. Because our graph is our submarine is constantly going up, that means every point on this graph represents a possible combination of time and depth. Let's talk for just a second about the domain of this function. You'll remember from our function unit that the domain is where our x goes, or in this case, our time goes. How far right and left does our graph extend? Notice that our graph started at 0 seconds, and we're going to continue rising until we reach the surface here at 16 seconds. We don't really know what's going to happen after we reach the surface. We might go back down, we might stay, but we can't really make any predictions about this. The information is not given to us. We also don't know what happened 1 second ago or 2 seconds ago, so we can't really talk about what's happening back here at -1, 2, 3. Because of that, our graph only goes from 0 to 16. So when I give my domain, I say every time will work as long as I'm talking about times between 0 and 16. Notice that I should have equal signs on here because we do hit 0 seconds and 16 seconds, so I will need to go back and add those into my slideshow. The range talks about where the graph goes up and down. We're told that our process or our pattern starts at 4,000 feet below the sea level, and we're going to go up until we reach the surface. We can't predict whether or not this will go above the surface, although I anticipate if it's a submarine, it probably will not. And we certainly don't know what was happening before we started counting. Because of that, my range is going to go, any depth will work, as long as that depth is between -4,000 feet and 0 feet. That's your domain, that's your range. And again, I left off my equal signs. I will have to go back and add those into my slideshow. We're asked to interpret the intercepts. The y-intercept, where I'm at here, tells me where I began. I began at 4,000 feet below sea level. My x-intercept up here tells me when I reach 0 feet, or how many seconds it takes for me to reach the surface. Notice this says 32 minutes. Again, this is riddled with typos. We surfaced after 16 seconds, or sorry, 16 minutes. I think we've covered everything. That's about all there is. Did we get it all? Interpret the slope. I did not describe the slope down here, but we did say that the slope is how fast we are ascending, so certainly you might want to write that in as well. That's really all I have for today. I tried to be very thorough and cover really anything and everything that could possibly come up in terms of dealing with slope-intercept form. We do have some other issues that are connected to this that we will talk about in our next video, but I think that's probably going to be more than enough for today. As always, thank you for joining me. I do wish you all the very, very best. Take care of yourselves. Bye-bye.